Hi, I'm Avi Bernstein.
And I'm Yosef Bordak.
Yosef and I are sophomores in Yeshiva University's computer science program. This summer, we spent constructing a data store mentored by Yoel Spotts. Yoel is currently a senior software engineer for Elastic.
Without Yoel, our entire project and summer experience would have never been as valuable as it was. Thank you so much, Yoel, for spending the summer mentoring us. We are grateful for all that you've taught us, both in terms of software and in being a professional and in being professional engineers. We would also like to thank Judah Diamond for organizing the entire summer program. Our data store was comprised of three components and stages. First, we created a group user dynamic that mimics WhatsApp's and Facebook's famous group user model. We created a platform where you can create a group and add users accordingly to that group. Secondly, we transitioned from hosting our entire platform on one server alone to using many servers coordinated via a hub. And lastly, we addressed what would happen if a server went down using health checks. In other words, if a server experienced trouble, we would automatically be updated regarding the server's challenges.
So stage one was spent converting group and user Java objects into database tables. Through REST API, we were able to create, read, update, and delete group and user tables. These operations are otherwise known as the acronym CRUD. Now, REST API stands for Representational State Transfer, and is referring to the data that is being manipulated. In other words, REST API allows a server to respond to a client's request for data and respond in a standardized way, such as sending data back in the form of a JSON array, as shown in the bottom right corner.
A common challenge API teams have is needing a database to run and test their code. In our case, we needed a database designed for our group user dynamic. But we weren't working on database design or construction this summer, and so we wanted a way to automate the process of creating a database. Accordingly, we used a type of Java persistence API to create a database using normal Java objects. So in other words, instead of writing the SQL code like this on the left, we were able to simply write a plain vanilla Java class, as you see on the right, which JPA then converted into database tables. Specifically, we use Panacea entity as our JPA to persist the Java objects.
Java objects that are being persisted are known as data transfer objects, or DTOs. There are two ways to persist Java objects. One is called an active record, which is where the Java object that you are going to persist has methods inside it that accomplish the persisting logic. So as you see in the bottom left, the entity that will be persisted also has a method to persist itself. The second way to persist a Java object is by using what's called a repository pattern. This way, you have a class that alone does the persisting and is separate from the object being persisted. So if you look at the bottom right, there's a separate class called repository that is persisting the Java entity known as entity. When constructing a distributed system, there's no real difference whether you use a active record or a repository pattern. Nevertheless, we chose to use the repository pattern because it coincides with loose coupling, and it made organizing our file structure simpler.
For our database, we chose to use an H2 database rather than a conventional SQL database for a few reasons. In general, an H2 database was more friendly towards development in contrast to production. More specifically, there are three reasons why it is more tailored towards development. Firstly, it's embedded in Java, and so there's no need to run a separate application. Secondly, there's an in-memory option, which is just useful for testing. And lastly, an H2 database comes along with a user interface to view what is being stored. So in contrast to needing to run to the terminal in order to view your database, you could simply use their user-friendly user interface.
Now, it's also a huge hassle for teams to develop their own interface for testing their REST API. Therefore, we use Postman, which is a front-end user-friendly way to run REST API.
As a program's user base grows, it is common to run into scalability problems and the demand to attain higher standards for the program more generally. Accordingly, for our second stage, we distributed our platform into multiple servers. Doing so, transitioning to serving our platform onto multiple servers, heightened three crucial components to our platform. Firstly, it allowed for more efficient memory allocation. In other words, a single server only has so much disk space. However, distributing the data onto multiple servers means that less memory is being used on each server. Secondly, distributing our platform onto multiple servers allowed there to be faster execution. The faster execution was led to for two reasons. Firstly, the database has less data and accordingly can execute its queries faster. And secondly, there's less data in memory per server because each server is only storing its relevant data in memory and accordingly can operate faster. And last but certainly not least, there is potential for higher security. In addition, an additional feature we would add in the future would be to require a user to be part of a group in order to access that group. If you were to add such a feature, having multiple databases could add an additional layer of security, because even if one database is like hacked, the other databases could remain secure and untouched.
So how did we construct our program to use multiple servers? So each server represents an individual group, and each server has the URLs to all other groups that are created. Now, if you look at the diagram, you see that there's a lone server that's called the hub. The hub's responsibility is for updating the URL maps whenever a group is deleted or created. So if a group is deleted, it will remove that URL map and update the group's URL maps accordingly. Now, it's one thing to have multiple groups running, but how do the multiple servers running? But how do the servers communicate with one another? So to solve this, we use Client API. Client API connects two servers by passing in the server you want to connect to, passing in that URL. As the application is running, the application will be redirected to that server's URL, and you'd be able to do CRUD operations on the connected server's data, or for our application, the hub is able to connect to all of the groups and update their maps.
So we chose to use Web Client as our client for our platform. Why did we use, the question arises, why do we use Web Client over more popular conventional clients like Java's HTTP client? To kind of support that question or strengthen it, the general consensus is that HTTP client will likely become the dominant Java client in the near future. Additionally, HTTP client is built into Java, and generally it is better to reduce dependencies when it's possible. So why do we use Web Client? Because it's more flexible and efficient and tailored towards development in contrast to production. In other words, Web Client's not actually a client itself. It's an abstraction over other clients, which was created specifically for the purposes, or largely for the purposes, for development purposes. And therefore, we chose to use Web Client for development, since our project was mostly focused on development and not production. And so therefore we use Web Client and not HTTP client.
Now, adding health checks was the third stage of our program. Specifically, the hub periodically checks the other group servers to make sure they're running properly. In the event that a group server goes down, the hub will immediately remove it from its URL map and update the URL maps of all the other group servers. Now, we ran our application through a software known as Quarkus. Quarkus allows you to run a web application through Java code, similar to how Flask operates with Python. One advantage of using Quarkus is developers are able to make changes while running Quarkus, and Quarkus will immediately process those changes.
So why do we use Quarkus over the other popular options like Spring Boot and Peloton? So the first reason, as Avi mentioned, was that it provides hot reloads. An additional reason is that Quarkus provides more than just an application framework. It provides the necessities, some necessities around Docker and Kubernetes. Now we would like to discuss some challenges and accordingly lessons that we learned from this summer. Bernie and I got along very well from the outset of the project. But it took us a long time to get to the strong duo that we are now. The biggest challenge we learned and experienced this summer was how crucial communication is for the success of any relationship. Our relationships are, at the very least, based on some set of standards for each other. And if you don't know what another person expects of you and you care about the relationship with them, then you should ask what they expect of you. A second lesson, which also relates to communication, that we learned this summer is how important ongoing communication is. Just updating someone on how on your status and how your progress is going, or if you're struggling with something, goes a long way. Just so they know where you're at in terms of where you're at and how you're spending your time. We both struggled on these 2 points. We both struggled a lot in the beginning of the summer, but we believe that we really learned and gained from our experience. The last lesson we, I guess, gained from the summer that we'll discuss, we gained a lot from the summer, but the last one we'll really focus on is how to identify which tasks are best programmed together and which are more efficiently distributed and accomplished separately.
Now, it's always possible to improve your application. So here are a few features that we would like to incorporate further down the line. One is incorporating ngrok. Ngrok allows people through the internet to access your local host web application. The second thing we'd like to incorporate would be a batch request. This would allow one server to upload a user to all the other groups simultaneously, as opposed to each group adding that user asynchronously. And lastly, as Yosef mentioned earlier, we would like to incorporate higher security such that only if you're a member of a group can you access that group. Okay, so this is the demo portion. And to mimic multiple servers, we have multiple terminals running with different port numbers. As you can see, that's 8080. As you can see here, the health checks are running 8081, and the other terminal is 8082. So the first step is in CRUD operations is create. So first we'll create a bunch of groups and users. So group 1, we have a group, wonderful. Here we're going to call this user 1. We're going to make a user for group 1. And honestly, we're going to make 2 users for group 1. So that we could do a get. So that was create. And I guess we'll quickly do something. We'll create a second group. And we'll make a user for fine. So as of now, we created with post CRUD, we created 2 groups and 3 users for that group for in total, cumulatively. Now, if we want to get a specific user, all we have to do is plug in the group number with the group ID. So I'm with the group number with the username, and we could get that user. So if I were to do 1, so we would just get user 1. If I were to do 2, we would get user 2. Now, so that's read. So we created a groups and users. We're able to specifically query for specific users. What if I want to delete a user? So to delete a user, I would just put in the name, the ID that I want to delete. So let's say I want to delete group 2. So right now, if I want to query for group 2, we get it 200 okay, so code. If I were to delete, we should get a 204 no content, and I should get a 404 status code since it doesn't exist anymore, or a 200 but it doesn't exist anymore. Nevertheless, if I try to get user 1, that was never changed, so user 1 still exists. So we were able to specifically we're able to delete a user. What if I want to update a user? So right now, user's name is user1. So let's change that to make it have an exclamation point. So we'll call this user1 exclamation point, and we'll update 1. And voila, looky here. The name is for user1 has been updated. So those are simple CRUD operations, for specific users and groups. Now, again, we want to show that the groups as of now, we have multiple servers running, and group 80, the localhost 8080, it doesn't necessarily know of the existence of localhost 8082. So that's the beauty of the hub. The hub was able to connect the two groups together. So if I want to get their maps, group 8080 has the map of 1 and 2, and 8082 group 2 has the map of 1 and 2. So we're able to, so those are basic CRUD operations, and we know that group 1 is aware of group 2's existence and vice versa. Now, there's something called a redirect, which is where if I want to get a specific group and user, so if I want to get a specific group and user, sorry, let's say I want to get a user, but I'm not connected to the group. So what will happen is the group that I'm connected to will look through its URL map and find the group server that has that user and then send me back the user. So group 8082 has user 3 inside of it, right? So if we do this get, we have user 3, wonderful. But let's say I'm connected to group 1 and I don't have that user. So postman, so what'll happen is localhost 8080 group 1 will redirect me to group 2. So if we go to settings and we turn off the redirect, link. So what'll happen is we'll get a 307 redirect response, since as we see over here. And if we turn back the settings, the redirect to actually follow the link, I should get the actual user, even though it's not in group 1, since group 1 will go to group 2 and actually get me user 3. So again, we did CRUD operations. We know that there's a connection between group 1 and group 2, even though they're totally separate servers, and we're able to do a redirect. The final thing we'd like to show you is the health checks. So again, health checks are periodically, if you look over here, they're periodically checking whether or not a server is down or not. So let's just mimic that now. So let's turn off group 2, and we'll have to wait a couple seconds. But so we already said that group 1 was aware of group 2, and group 2 was aware of group 1. We should wait a couple seconds, and hopefully the map will be updated. Any second now. Oh, voila. And because again, the hub realized that group 2 was shut down, and it updated the maps accordingly. So this has been our summer project for the industrial software course 2022. We'd like to thank Yoel again for mentoring us. We really appreciate it. And we'd like to thank Judah for organizing the course.